Hi all. Now we are going to see second unit. The first topic is normal and abnormal ECG waveform. Okay. So first we should know what is mean by ECG. So ECG is mean by is electrocardiography. This is the technique which is being used to study the electrical activity of the heart muscles. Okay. So the output which you are getting from this device is nothing but electrocardiogram. The word ends with gram is nothing but is the output or the result which you are getting from the device. So that is it says the recording pattern of ECG. Okay. So this what actually this electrical activities represent in the sense it is nothing but the heart muscles function. That is the status of heart muscles. It represents or reflects the electrical depolarization or repolarization of myocardium. That is a contraction of atria and the ventricles. Okay, so in that if you see the recording of ECG, all waveform we are analyzing in aspects of shape, time interval, and amplitudes. These three parameters carries a meaningful information, and it says the conveys the meaningful details about the state of the heart. So that is why this ECG is very much important to study the electrical activity of the heart muscles. Okay, so this is the basic one, the heart structure. You know what is mean by heart, how does it look. If you close your wrist like this, then this is going to be your size of the heart. You have the four chambers, two atria and two ventricles. So if you see the circulation, the impure blood will goes to vena cava. All impure blood from the body will goes to inferior and superior vena cava. Then it will go to right atrium, then right ventricle, then it goes to pulmonary artery. From there it will goes to lungs, where all the deoxygenator will get purification between process will happen between alveoli and the blood vessels. Between these two, the purification process happen. Once all the blood being oxygenated, then the pure blood will go to left atria through pulmonary vein. From the left atria to left ventricle, then from left ventricle it goes to aorta. From aorta is the biggest artery vessels. Then from there it will distribute it to all parts of the body. So this is the general structure of, I mean, the general blood flow of circulation of blood. Okay, so this here on right side of slide I have given the anatomical structure of heart with different parts. This is the basic one. I think you might know everything well before. Okay, now I'm getting into the origin of cardiac action potential, because today topic is we are going to discuss normal ECG and abnormal ECG. So first we are going to see the normal ECG. For that we have to know how these ECG signals is being generated, how we are going to capture. So that is the thing we are discussing here. So the reason of generating this electrical action potential is, that is a cardiac action potential, is these four nodes. That is SA node. We can also say the natural pacemaker. Then second one is AV node, and you have a atrioventricular node. That is mean atrial ventricular node. Third one is bundle of His, and fourth one is Purkinje fibers. These four things is main reason for cardiac action potential. If you have problem with any of this, then the respective action potential will not spread out to the heart muscle, so that you will have problem with synchronized contraction relaxation of heart muscles. Okay, so these are the places where you can have the location of SA node. This one is then AV node, that is the between atria and ventricular, and then the middle of the spectrum you have with the line between both right ventricle and left ventricle. You have the spectrum over which you can see the innervated of nerves kind of thing. That is nothing but your bundle of His, and then from bundle of His you can see the branch out of so many nerves like thing. That is nothing but here Purkinje fibers. This will ensure it's being covered all the ventricle side. Okay, size of all the ventricles from bottom to top. Okay, so that once the pulse reach to this Purkinje fibers, all the ventricles will start to contract. Okay, so the conduction is, it will start from AV node. Once the SA node, the SA node will receive the impulse from instruction from brain, so that the SA node will start to generate the impulse. So these SA node will transmit to all the both atrias, and slowly so that atrial muscles will start to contract. Okay, then from the atria, then it will goes to AV node. This also cause the delay length, because that is the time it's needed for the atria to fill the blood and to contract So contract, so it's the time needed by the ventricle to fill it. Okay, and then you have AV node. The AV node and now it will generate the impulse, so that impulse slowly moving or marching towards the bundle of fist and the Purkinje fibers. When it's happening all this way, the vertical muscles will get excited. Heart muscle will get excited. It will start to contract. As a result, the contraction will happen. So the blood will be pumped and go to the respective places. So this is the whole thing is happening because of these four nodes. Okay, so we will have a relation related with ECG. All these nodes, how the ECG signal is being produced. This is nothing but isoelectric line. Before starting ECG signal, you will have straight baseline. This baseline is represents the resting potential of the heart. Okay, so this is called isoelectric line. Then we will have first stage, that is a SA node depolarization. As a result, you will can see the P wave generation. See here, this is the P wave generation. So this is the point. It represents the atria will give the impulse to the both the SA node will give the impulse to the both atrias. As a result, the atrial will start to depolarize. It means the atrial will start to contract. Okay. Second one is QRS complex, that is the point where the AV node will spread the impulse to the Brundtleoffice and Purkinje fibers. So the now the ventricular muscle is now start to contract. As a result, you can see the waveform changes here. So you can have a QRS complex. So this QRS complex is a representation of ventricular contraction. At the same time, you will have the relaxation of atrial repolarization. Okay, that is the atrial relaxation or atrial repolarization. That both things happen at the point of QRS complex. So next one is the T wave. That is the point. This is the waveform of T wave. These waveform T waves represent because of depolarization of contraction of ventricle. That means after contraction of ventricle, it has to regain its original state. That is the repolarization. So this is the T wave. It's representing the repolarization. That is the resting state. It's trying to it's trying to come back. Okay, back to normal. So that state is represented by T wave. The reason why the P wave is smaller than T wave means here we are representing this T wave is a ventricle. So you know that ventricle size is its size is bigger than atria. So the relaxation it will have much amplitude compared to here. That is the reason your P wave is very smaller than T wave. Okay, so now as a whole, if you see the ECG waveform, it starts from P, Q, R, S, T. Okay, so P wave is representing the origin of P wave is because due to the atrial repolarization, or you can say the contraction, the amplitude is 0.25 and duration is 0.12 to 0.22. That is the PR interval. Second R wave, that is the we can say the QRS complex. This complex represents that repolarization of atria, or you can say the depolarization of ventricle. Okay, so that amplitude is 1.63 millivolt and duration is 0.07 to 0.1 millivolt. And T wave is the ventricular repolarization, that is the relaxing of ventricular muscles. It have a waveform with an amplitude of 0.1 to 0.5 millivolt and duration is 0.05 to 0.15 duration, that is the ST interval. Okay, so XT interval is representing that is nothing but the ventricular contraction in duration, that is the ventricular interval. And U wave, this wave will not be seen in all the type of ECG waveforms. This wave will vary person to person. Some person will have this type of wave, but it is not much wrong in that when the person have this U wave. The U wave, if you have or if you witness this U wave in any ECG waveform, what it tries to represent in the sense it representing slow repolarization of intraventricular system, that is main function of Purkinje fibers. Okay, it represents the Purkinje fibers status, that is U wave. Okay, so if you have that U wave, then it should be like falls less than 0.1 millivolt and duration is 0.2, that is T to U interval time. Okay, this is the overall standard ECG waveform and the origin of the ECG waveforms with their amplitude and duration. So this is the, if you see any and data or any values or any yes, any datas or values, it founds in ranges. The reason is that there is no one specific value or one standard value as far as the medical term concerned, because all these parameters, all these datas will be vary from person to person in respect to their age, size, are so many factors. Okay, so you have everything in terms of range, so that if the value or parameter which is falls under that range, then it is the normal. If it is goes beyond that range, then we conclude conclude as a abnormal. So as like that, here also ECG waveform, each waveforms have the range of amplitudes and durations, standard ranges. So if again the persons, when you are monitoring or recording these values from persons or patient, that value should fall within this range. If it is not, or if you have any physiological deviation or deformation or any range which is goes beyond or under a limit, then it may end up with abnormal ECG waveforms. So in this class we will see what is the abnormal ECG waveforms, that is arrhythmias with real with example. Okay, thank you.